Hey everyone, welcome to episode 3 of Cloud Masters, a no-fluff cloud podcast giving you tangible tips for navigating the cloud. Today, we're joined by Martin Borek. He's a technical product manager of the platform engineering team at Krys. I almost said Cry. Krys had a 6-figure AWS spend that they managed to reduce by roughly 70% by implementing somewhere between 10 to 15 different cost savings initiatives. Some of that involved, of course, purchasing RIs or savings plans, but we're going to focus on some of the more interesting and, for some of you listeners, perhaps lesser known initiatives that they did. But before we dive into that, Martin, could you give a quick overview of what Krys does and what your role and team are responsible for?
Absolutely. And thanks, Matan. Thanks, everyone, for inviting me here. It's a pleasure. So, like you said, Matan, I'm Martin. I work as a technical product manager at Krys. And Krys, for those who don't know, so we are the Europe's leading digital healthcare provider. We operate in 4 different markets. So it's in the Nordics. So that's Sweden, Norway. Then we operate in France, and we are also in the UK. We have roughly 5,000 healthcare professionals. So that includes clinicians, nurses, and also specialists like psychologists, dermatologists, and so on. And we are not only digital, we also have physical clinics. So we have over 50 clinics in Sweden, Norway, and France. And so far, I believe we've had around 8 million appointments with patients. So I think that the numbers are amazing. I always love to say this. And a little bit about my role. So like you mentioned, I work as a technical product manager at Krys. And I work with the platform engineering team. So it's sort of the team that is providing the internal platform for the engineering organization. So we take care of things like developer experience, CI/CD, infrastructure as code, core infrastructure, security, reliability, and all these fun pieces. Basically, the things that we can do centrally to help the rest of the organization to move faster and to sort of comply to the security standards that of course are extremely important for us as a healthcare company.
The first thing that kind of caught my eye were you sent me a long list of the savings initiatives that you implemented to reduce your spend by roughly 70%, and a couple of things stood out for us. First thing being some of the things you did around Datadog. You talked about, you mentioned switching from a pull-based approach to a push-based approach for your Datadog metrics. And this primarily revolved around reducing the get metrics API cost. And I think, Sam, isn't that what we talked about we talked about it also separately. We had a separate webinar or a separate podcast about this specific cost as a red flag in your cloud bill. You should pay attention to this thing.
Yeah, that's exactly right. So for a bit of background, and then we'll get Martin to tell us a bit about the story at Krys. But essentially, whenever you're using a third-party tool to do monitoring of the cloud, they normally have to do API requests against your account to get that data. And so Datadog's not the only one. There's a lot of others that work the same way. And typically they'll query your CloudWatch metrics, for example, in AWS. And when they query that, it gets billed against your account. So in addition to paying a percentage of your spend to that company, you typically have something along the lines of the get metric data API request checked every few minutes or every few seconds in some cases, depending on the granularity that they're working, and pulling in all the data about your accounts and about all your running instances and how much network traffic they're using and all those sorts of typical monitoring data pieces that you would expect. The thing is that in most cases, that's something that's quite hard to adjust. You can call those companies and ask them to slow down their rate of checking your accounts at the cost of you lose then your real-time information. While I was chatting with this particular topic with Martin one day, he actually came up and told me about a solution that they'd found and how they were going to address that at Krys, and they were just about to do it. So I was following it really closely. Martin, do you want to tell us a bit about it?
Yeah, absolutely. And it's actually interesting that with this specific initiative, or how to call it, is not something that we really planned. because it's something like we started like being like more like cost conscious like roughly what was it, a year ago, and we knew there were some things that we can fairly easily save money on, but we didn't really think that this would be a possibility. Because I remember like long time back, I looked into like CloudWatch being fairly expensive. I was like, okay, like we use CloudWatch, not this much. Like, what do we pay for? And I think it might be more than 2 years back when I saw that, all right, we are paying for the get metric data API call, like you mentioned some. But like after like doing some Googling, it seemed like, well, there is nothing you can do about this. And I sort of saw it as like, all right, so it's basically AWS trying to protect themselves and sort of like encourage you to use more like CloudWatch, like instead of using solutions like Datadog. And it was really annoying, because for me, like then when we would say, all right, how much are we spending on Datadog and monitoring? So we would look like into the Datadog piece, but no one really looks into like, okay, how much are you spending on the AWS side for sending data to Datadog, right? So actually we had to combine these two together. But yeah, it was I think it was like 6 months ago ish when I ran into the article. I think it was it's an article from Datadog where they mentioned like there is an alternative way how we can ship the metrics from CloudWatch to Datadog, and they talked about the push-based approach instead of the pull-based one. But what was interesting, they did not really talk about cost, at least not in the terms of when they would say like this would be cheaper. They actually said like this is likely gonna be more expensive. So they only mentioned that like this is a solution that you should use for lowering the latency. Sort of like there is lower delay between like seeing the metrics in Datadog compared to how we would see them in CloudWatch. But since we knew that like we wanted to reduce cost, we said like let's give it a try. Let's see like how much expensive it would be. And it ended up saving, I think it was like 70-80% of the cost that we paid before on the on this specific API call. And actually it almost fully eliminated the cost for it, but actually it introduced another cost, and that was for, I think it's basically for sending the data using the CloudWatch metric streams, because there's also something like the AWS is charging for. So that's why we did not manage to save fully like 100%, still 70-80% is a massive saving. But what was interesting there, that like we actually had to play around with it a little bit, because for some integrations, I think it was one of them was a load balancer, we would actually pay more using the push method compared to the pull method. And I think it depends a lot on how many resources you have and how much metrics those resources are providing. So I cannot actually remember which one was the most expensive one, or actually I can. It was databases, because for each database there's loads of metrics, and there we don't even look at all of them. So for us it was quite easy to say, well, we are interested in these 5 to 10 different metrics types. So those are the ones we want in Datadog. The others we don't really care about. And this push-based method actually allows you to select which are the metrics you are interested in. So you can select like the whole like namespace. So it can be like namespace ALB, it can be namespace RDS. But you can also specify the exact metrics that you want to ingest. And I think thanks to that, like we managed to save quite a lot of money.
Yeah, it's a really elegant solution. And as you said, I mean, it's not the sort of thing where one size fits all. It doesn't work for every situation. But what I really liked about it as well was what you just pointed out, where you could tune the data you're sending to Datadog instead of them just taking everything. Everything obviously being relative here, but you're able to say, we only worry about these databases, and therefore we only want to pay for monitoring those databases, right? So I think it's a nice benefit that you've got.
And another thing that you did with respect to Datadog is you also, I think it was, you sent Fargate logs or ECS Fargate logs directly to Datadog. You also skipped CloudWatch over there. Was that for the same reason around cost? It was just less expensive to just send it directly?
Exactly. So like since we are now more cost conscious, so we look like into the different services we pay for in AWS, and they're like where it would make sense to actually find some different solutions. But also like we needed to make sure that like we don't compromise data integrity, we don't compromise reliability and other pieces that are important to us. And in this one, so for the logs being sent directly to Datadog, is something we need to be a little bit careful about, because when I look back to like roughly a year ago. So we had logs in 2 different places, and we would have logs in CloudWatch, and we had them also in Elasticsearch or OpenSearch instance. But since the OpenSearch instance was not given that much love, so that one was flaky. So it would sometimes happen that like not all logs would end up in OpenSearch. So that's why developers then would use like as a backup solution CloudWatch as a place where to look for logs. And then when we switched from OpenSearch into Datadog, then we were still running 2 in parallel, right? So we first would log everything to CloudWatch, and from CloudWatch we would use Datadog forwarder that would like send the logs to Datadog logs. And then like we needed to build trust in the organization that Datadog logs is something that we can believe in. So we don't need the backup solution in CloudWatch, because at the time we were paying basically for 2 different solutions while we were using only one. So it took us quite some time until we built the trust, and we saw like the Datadog logs is a robust solution we can use, and we don't need the failover one. So then it was only about how do we update the technical solution so that we can send the logs directly from Fargate, and we don't need to use CloudWatch. And that's where we looked into file lengths, and together with basically introducing the new container that is running as a sidecar to the application and to the other containers that we have in ECS. And that's the one that is basically that is getting the logs from the application container and then is forwarding to the Datadog API.
And so the main concern was about would the organization trust the data? It wasn't a compliance thing sending directly to Datadog or anything like that. It was more around just, people looking at Datadog at the logs there, and eventually getting to a point where enough people are like, all right, this has been giving you reliable data over a period of time, and you're just building a consensus from there to eventually send everything directly there.
Exactly. There was actually no problem with compliance, especially because once we introduced the Datadog logging, we also introduced the scrubbing of the Datadog logs. So we make sure that even if someone would accidentally log any sensitive information, it's scrubbed before it even reaches the basically the Datadog logging interface.
And the main result here, was the main result just reduce CloudWatch costs again?
Yes, that was basically it. I'm also not sure if it's any faster, the solution. Possibly, should be.
Before we go into the next one, what was the trigger that even got you on this path to like, okay, we need to start saving money, and you eventually went down this rabbit hole of 10 to 15 different cost savings initiatives? Was it just like a month where you're just like, wow, costs really spiked here, or we're seeing our costs gradually increase? What was the kind of the trigger for doing all this? And because you mentioned you only just started becoming cost conscious, so maybe what was the trigger for that? And then for this specific, this set of initiatives that you embarked on.
Right. Yeah, I think it's important to look like at the aspects that we need to take into consideration when we are building solutions or like updating solutions. And when I started working at Krys, it's roughly 3 years ago, so we were in a massive growth phase. So we basically proven ourselves as as a startup that works, the solution works. So we focus on video consultations. And then at that time, we needed to be fast. So we wanted to grow fast. We wanted to make sure that we have a good market share. We can attract new employees. We can make developers work faster, being more productive. So at that point, we focused a lot on productivity and on growth. So basically, the scale was more important than the actual cost. So that was the main aspect. Well, the main aspect always was the data integrity and data security. But then there was the other one, and there was the growth. And once we were a certain scale, then came another one, because then we became already big company that patients and clinicians relied on. So we needed to introduce the aspect of reliability. So even though like it was there, it was not the primary focus. And now we need to make sure like high availability is crucial. So then we introduced that one. But then like once all these pieces were working, then there was also a bit of a change in the market. And then it came, all right, now, well, cost is another factor that we need to integrate within the already existing ones. And that's something that like first we didn't really focus on. Well, a bit for sure, but it was more like growth is more important than the actual cost effectiveness. But at this point, we realized now to be a proven solution that's actually going to help healthcare at scale, that we need to be also cost efficient. So then it was a change of mindset in the entire company. And from the platform perspective, we saw, well, our main cost is in the cloud. Our main cloud solution is in AWS. So let's look into that one. And are there any like quick wins we can do? So initially we thought we might save maybe 20, 30%. So we never really thought we would get 70%. I think now we are going to get even further. We have some more initiatives now in the pipeline that might get us into like 80% saving. So at first it was more identify how we can do any quick wins where we can save money quickly. And from that moment on, it was just it was a mindset. And it's not even just the team I work with, the platform engineering team, but it was the entire company. So what helped a lot was just to show the data to everyone, show the data to everyone in the company. We pay most for maybe databases. We pay most for right now this. Now we pay more for this service. And then the teams that work with those solutions would look, okay, so how do I contribute to the cost? Is there something I can do a bit better? So it's actually interesting that lots of the solutions that we implemented didn't even come from the team, didn't come from me, didn't come from the upper management. It was just an engineer who would say like, well, why don't we do this a little bit differently? Like, well, there is this option. Like one of the initiatives I sent you was just moving ECS Fargate load from x86 to the ARM-based architecture to be running on Graviton. It's something that came from an engineer. He said like, well, this should be fairly easy to do, and it's going to save us 20% on our compute cost.
Did you call it FinOps at the time, or was it just, let's be more efficient in the cloud and that's it? Because, FinOps movement, a lot of what you're describing, changing the culture, engineering is kind of taking their own initiative, and a lot of that is just FinOps, or FinOps defines itself. The foundation defines FinOps as kind of doing that. And like you mentioned, the first step is making engineers aware about what we spend on what services, and even more specifically, what each engineer is costing, or what each team is costing, or each product.
Right.
So,
yeah, we didn't really call it FinOps, but there were jokes in the teams, and I would say like, well, we were DevOps, then we were DevSecOps, now we are DevSecFinOps. Like, what comes next? Like, it's gonna be like a massive paradigm.
It is incredible though. I mean, it's an example of sort of an organic growth of FinOps as a movement, but without necessarily calling it that within your company. Within FinOps, they talk about this Prius effect, right? Like if you've ever driven an electric car, and you put your foot down on the accelerator, you see the battery drop really quickly, your distance to empty comes down, and you suddenly start driving a bit more conservatively. And it's the same thing with cloud spend. When you start showing it to people, when they start realizing how much their latest feature or latest change or latest push costs, then they start reducing those costs. And there are some certain cynical people around that'll say engineers don't want to do this, but the proof's in the pudding there, where you say engineers want to be efficient. It's just that sometimes they don't have the time to focus on that, and the backlogs of new features are a little bit more important. I think any company would be pretty happy to reassign some engineers for a little while and get 75 or 80% savings on their cloud bills.
Yeah, we also said it's not only, right, like the engineers need to be given the time, they need to be given the trust, but also they need to be given the data. So it's something that's like, for me, like for the best AWS service was Cost Explorer. And like once we onboarded to do it, so some told me is like, well, just wait to see what we've got. It's even better. Well, it's good. So that's basically my morning routine. Just have a look at like what did we spend money on yesterday? How did it change to the day before? How is it changing over weeks? And since I want to be replaceable, so then I also I did some automated alarms that we can look into together with the teams, because I believe like some of the things, like it would just be deteriorating over time, right? So like if you look at it, like now the cost is in pretty good state. But if we don't look at it any further, it's just gonna keep on increasing. And we don't notice it. It's gonna increase 5% here, 5% here, and in 1 year it's gonna be like additional 30%. I think it's important to catch it like right away. Like if someone is now implementing a new solution, like they want to know, well, this is maybe not cost optimal.
And going back to the next initiative that you already hinted at, as far as migrating to Graviton, maybe just a level set. I hear about it a lot. Why does it seem like the hottest thing now is to migrate to ARM Graviton? And is it something that everyone should do? Is there certain specific use cases here? Before we go into like what you actually did, maybe an overview about Graviton, either from Sam or you, if either you want to cover it.
I can start a little bit because this came out while I used to work at AWS. But Graviton is it's a new architecture. Well, it's not a new architecture, but it's a new processor line developed along the ARM architecture by a subsidiary of Amazon. So years ago, Amazon bought a chip maker called Annapurna, and they used to make, they still do, make boards that go into the AWS instances to do all the virtualization so that they take the load off the system and make that more efficient. They then decided to put a big push on these ARM processors, which are used in loads of different applications all over the world, including Raspberry Pis and things like that. But they realized that in commercial compute, they could actually run more efficiently and cheaper, less electricity, everything else, and provide pretty much the same compute power. So AWS then went all in on this, got Annapurna to build out some more chip building facilities, and they are now deploying those as an option for you to deploy alongside Intel and AMD with a different chip architecture into your systems. There's pros and cons of everything. Obviously, changes is always interesting, but I'm specifically interested in Martin mentioned in the previous discussions about doing the same thing with managed databases, but also with containers. And I think that's probably where one of the really good distinctions about running the Graviton processes comes, is the managed services versus the things that you have to build and compile yourself. So I'll let Martin talk a little bit about what was specifically done at Krys, and then maybe we can compare and contrast some of the challenges that you had and see how we go.
Yeah, I cannot really. I can comment on the like AWS side, like how much performance better the Graviton instances are. Like we've done some tests, it looked promising, but for us it was mostly like that AWS is actually pushing for using Graviton, so they incentivize us by like reducing the price for those instances, while theoretically being even like better from the performance side. But at first, like Sam mentioned, I think. You heard that like we first migrated the databases. So we run loads of databases. We have some bigger, some smaller. We run them on different instance types. And one thing was we wanted to also purchase the reserved instances. And we knew that like sadly AWS doesn't really provide anything like savings plan for databases. So we knew that we need to commit to a specific instance type. So for us it was important. Well, we need to make sure that we believe we are running on the right instance types. We know that this is roughly the load that we are going to run over the next one to 3 years. And only then we can do the commitment. And then we look into, so if we would make any change, what would it be? And then we saw, well, like it's quite clear, like we should go to the Graviton instances because they are, in worst case, they are the same, but cheaper, but they should be even better. So that's why we migrated the bigger databases. So that was the first step. And then we look into migrating all the other databases, because the way how we run at Krys is like we try to run like DevOps. So we don't control everything from the platform engineering team, but we do provide some templates. We do provide some Terraform modules, and that's also like how services would how the teams would provision their databases and also their services. So for the databases, what we did, well, it was fairly simple. We just updated the configuration in Terraform. But then the little bit problematic thing there was that we knew that to do it simply, we will require downtime. And at Krys, it's in some markets we run 24/7, like for example in Sweden, unlike in other markets where we might have some gap in the night. So we actually needed to plan for this. It was like a planned maintenance that we did at midnight, and it was, but then it was fairly easy. It was we wrote a script that would update it for us. Then we would update the Terraform configurations, and it was maybe 1 hour job, half an hour just the pure migration. And yeah, then voila, or our instances in databases for our now running in the Graviton architecture.
So did that need any or a lot of testing for you? I mean, one of the things I guess about managed services is if you believe people like me, then I say, well, it's managed, it's done. Amazon are taking care of all of that, and the same thing with similar products in Google. So I've got an endpoint to connect to, whether it's a Postgres or an Oracle or whatever database it is. I've got a DNS name and a port. It shouldn't mean any difference to me as a client system accessing that database. Did you have that level of confidence, or was there some testing that you did? How did that sort of play out?
So before this migration, we migrated the bigger databases, and those are the ones where we really care about performance, because the scale is significantly bigger. And for those, like, we ran some performance tests. So we ran like load testing on those to make sure like these actually do perform better. And they did perform at least as well as the previous configuration.
I guess armed with that success, you went and did the same thing with ECS, right? How did that play out?
So that one, funny enough, it's a bit more complicated for us, but not because, well, because I know that some of you mentioned to me like you thought it would be more complicated, but it's actually, we have been building all our service images on both architectures for quite a while, just because we want everyone to be able to like run the services also on their laptops, and so there wasn't really a problem with the building. But then, like, we want to make sure that actually the performance is what we expect from the services. So that's actually something we were not really confident, like, from the platform engineering team to roll out everywhere. So it's something like we enabled, but then we left it up to the teams. We said like, okay, this is available for you. We would like you to adopt this, but you need to run some performance tests before you release it in production. And I think there's also like this, there's a tricky situation, like being a central team and pushing something in the organization. So I had a look earlier this morning, and I think we had like 60-70% adoption. So it's not that all services are now running on Graviton. We still have a few left.
Sam, I guess what was the inkling that, like, what was it about, migrating from RDS? What was it about migrating RDS to Graviton versus ECS tasks that makes you say like, oh, this ECS aspect is more difficult or more complicated?
Well, I mean, the ECS part, obviously. So as I said, with a product like RDS, it's a managed database. You're connecting to an endpoint. Under the hood, to get that working, Amazon would have had to do some work, and the different database engines that they're running would have had to be compiled for that architecture and so on. That's all obfuscated away from you. You don't have to worry about that. When you're building containers, as you would be for ECS or Kubernetes or anything else, and you change that processor architecture underneath, even to a lesser extent when you change from Intel to AMD, depending on how specific your code sets can be, then you need to recompile everything, and you need to make sure all the different libraries and all the different things that you're using support that architecture underneath. And the ARM ecosystem, if you will, has lagged behind the Intel because it hasn't been as popular in production systems for big companies. That's changing these days with not just Amazon, but I mean, Apple have been putting the ARM processors in their Macs for the last couple of years now, and there are a lot more people using them. So a lot of the libraries and utilities and programs that we use regularly in a containerized system have now been updated, and it's okay to go ahead and compile that. You still need to obviously do all your testing and everything else because there's a lot more riding on you to make sure you got that right.
Yeah, that's exactly what I expected, Sam, that when he told me that you thought it would be more difficult. But for us, since we went through the painful process already when people started getting laptops with the new chips, then we basically had to solve it before we even looked into getting to Graviton instances.
And then of course, you've got all the performance comparisons, as you mentioned, to make sure that it's at least as performant as you require, and in the end saving you some money, hopefully, which we're lucky it did.
The last thing that at least we mentioned covering, but we can of course go into more initiatives, is under the umbrella of turning off stuff when you're not using it and deleting old databases that you're not using. And I think we'll start with I guess your non-production environments were initially turned on during outside of office hours. They're being left on.
Yeah, That's correct. So we had quite a bit, because of the way how we work with development. We had loads of non-production environments, basically that also had to do with the growth. And when I said productivity was the number 2 priority, and with that we had lots of environments that were also running over the weekends and in the night. So we looked into like what can we do to make these cheaper when actually no one uses them. And then we looked into, so what is our main spend? Well, our main spend was databases, compute. So let's look into these 2 solutions. Like it shouldn't be that difficult to scale it down, because we didn't really want to do like complete like kill the environment and then provisioning it from scratch, including infrastructure and everything else. So the way how we did it, so in databases, like it's easy to stop the instance. So sort of like we wrote a script that is gonna stop all the instances of databases, and then also a script that would then start them again. For ECS, it was a little bit more complicated. So the way how we solved it there is like we would look at the entire ECS cluster. We would look like at all the services, and then we would basically just scale them down to zero task for each the service. And then also the script, and then it would be wakening up the environment, would be the one who would actually set the task count to what it was initially. So there was a solution that we packaged in Insta functions, and then we would just set specific times when a CloudWatch rule would initiate these, and it would initiate it like first hibernate the environment overnight, and then wake it up again in the day.
So a couple of follow-up questions on that one, because I get them quite regularly from my customers. So I'm interested to see how you solved it. How did you identify what was a production workload and what wasn't, firstly?
Well, it was quite easy because we run production workload in completely different account and different VPCs as well.
Okay, so anything in this account is production, anything not in that account is not, and so you can shut down or scale down everything in the other accounts. That's easy enough. The other one then is in terms of identifying schedules. In some companies, people are working on different time zones or something like that. Did you just fire the script once a day and that's it? That's Friday afternoon, we turn everything off. Monday morning, we turn it back on. Or was there something that, for example, in the tags that you said this instance needs to be scaled up or down or on or off or doesn't get touched or something like that?
Right. So we were considering implementing the tags, but we actually did a little bit differently because we thought that it would not really help us that much. So let's say we had a bunch of environments. We might have had 10, 20, 30, I can't even remember, quite a lot of like non-production environments. So what we would then do, so we would actually give the flexibility to the teams to configure like when they want the automated rule to actually scale it down and scale it up. They could override it. And another thing that we later introduced was they can wake it up when they need to. So we also integrated within Slack. So when they want, they send a message and the environment is going to be up within 10 minutes and then they can scale it down.
The last thing under the topic of not using stuff or turning off stuff you're not using, you also just in general cleaned up unused resources like idle databases, old snapshots, unattached volumes, things like that. Was that also something you drove just centrally, or is that just something you encouraged every team or the engineers to do themselves, or how did that go about? Was it the same thing as the initiative with logs being sent directly from Fargate to Datadog, or kind of like an overarching mandate?
It was not really one specific initiative. This is something that like we had to like remind ourselves, like if you don't need this, just clean it up. But also there were like some like smaller initiatives around this, as like Trusted Advisor is a really good friend in this, that it shows you like what are the idle DB instances, what hasn't had any connection in the last 14 days, what are unused like or over provisioned EC2 instances, what are some EBS volumes that you should look into, and so on. So like parts of it was, let's look at Trusted Advisor, and parts of it was just teams being more conscious and look into like, are we actually using this service or not? Is this something that we can either change the architecture or we can clean it up? So I think one thing that I really loved about like these cost saving initiatives, it was it was not only cost saving. Because quite often we said, like, we are not going to do cost saving and introduce additional complexity. It was rather the opposite. It was like, we also are going to drive simplification. Because we said, like, well, we also want to reduce the cognitive load on everyone. If we have fewer services, we have less code, if we have fewer resources, it's so much easier to do our daily work.
It's a nice way to look at it. Are there any of the other initiatives that maybe you're particularly excited about that you wanted to talk about? We highlighted a couple, that we sort of picked off from your list, but are there any other ones that you find especially interesting that you want to walk us through?
Wow, I'm not sure. There was so many. It's like I cannot say like which is my favorite one. Like, you cannot say what is your favorite child. Actually, there was one that was quite interesting. It was because there was extremely simple, and there was the EFS intelligent tiering. So the EFS is like we store quite a lot of data on EFS, and the data was basically in the standard storage class always, and then like the data was just increasing in volume. It became quite expensive, but we never really thought like this is something we can challenge. We thought like, well, this is what it is. And then we looked into, well, that is something called intelligent tiering, and it's there is no risk. The only risk is like it's gonna be more expensive if we implement it bad. And we looked into it, we experimented with it, and then we reduced the EFS cost by, it was over 90%. It was ridiculous, and that was just one line configuration in Terraform.
Yeah, so the intelligent tiering it's a really cool and a similar one with S3. It's a really cool solution to just take that away from you, and you don't have to worry about it. The scary part is when you do turn that on, right? Some of the changes that I remember when S3, we spoke about this in our I think the last episode with Ian and the other terms. When we first turned on S3 intelligent tiering in AWS, people didn't realize how many operations would be involved in moving things, and bills went through the roof for a little while. But if you've identified your data access patterns, and you know that there's a lot of hot data, there's a lot of cold data that you don't access that often, then it's much cheaper to move it into the infrequent access tiers and things like that. So it's a nice solution.
Thanks for sharing all that with us, Martin. For whoever's listening, thanks for listening. We hope you got something out of it. I mean, if Krys could reduce spend by 70% with some of these tactics, I'm sure you could reduce spend as well. Doing a couple of these things if you're not doing it already. So yeah, we'll see you next time in the next episode of Cloud Masters.
Hi, thank you very much for having me, and thanks, Matan, for not butchering the pronunciation of Krys.
Cloud Masters is hosted by Matan Bordo, a product marketing manager at DoiT, and Sam Clark, a technical account manager at DoiT. Our guest this week was Martin Borek, technical product manager, platform engineering at Krys. Production and editing of Cloud Masters is handled by me, Crispin Standback, multimedia content producer at DoiT. To hear more episodes of Cloud Masters and learn more about how DoiT helps deliver the true promise of the cloud with ease, not cost, visit doit.com for additional resources.